in the previous section on stereoisomerism, I missed out EDTA. So I'm now going to go through that now. Okay, so EDTA. So optical is a hexadentate ligand. So hexadentate, remind yourself, means it's got 6 teeth. If you remember that dentate means teeth, but 6 means it's like, and it's a chelating agent. It's got claws. Okay, so it can grab on. Okay, so hexadentate is EDTA. Okay, EDTA will form optical complexes, so it will also show optical isomerism. Okay, so here is a diagram of it. So you got the metal in the middle. So I'm just going to make that and show you what it looks like. Okay, so the EDTA is basically made up of ethanoate joined to a diamine, 1,2-diaminoethane. Okay, so let's put this together. Okay, and let's go on to the nitrogen. So here is this EDTA molecule. It's got the lone pair on the nitrogens. That's the lone pairs on the nitrogens, and it's got the. I've drawn that on the wrong way. Let's get that right. Okay, and I've done it wrong on the other one. So that is, yep, that one there should be there. So it's the carbon that joins the nitrogen. So we've got the oxygens free. Okay, so the oxygens would have had hydrogen on. Those hydrogens have come off. Okay, so now this is 4 minus. Okay, so it's 4 minus because we've got these 4 oxygens without a hydrogen on. So if we bring in our metal, okay, so here is our metal here with 6 joining points, so it gives us the octahedral. So let's join on the nitrogens first. Okay, so that's 2 lone pairs that have joined on, and then we have got the oxygens to join, and they are negative. Okay, so they're going to push their electrons onto it like that. Okay, and like that. Still gets a little bit tight to get it around, and then this one needs to go on here like that. So this is, and should ease all up nicely. So this is the complex with EDTA. So it looks a little bit complicated. You can start to see how, you know, we can get all these metals in cages, like the heme group. Okay, so this is EDTA, and this, you know, because of structure, if I made the reverse copy, it would be different. Okay, it would be different to this. Okay, so the nitrogens are at 90 degrees to each other in the complex. Okay, which hopefully you can just see through there. Let's put it up against the wall. Yeah, it's probably better. Let's try and get into a decent angle. So yeah, so the nitrogens are joined on at 90 degrees to each other, and that is just like this diagram, which I'm now going to share with you again. Okay, so there's this one here, and you can see there's 4 negatives on here, and this metal, okay, oxidation state of the metal, well, it must be 2+, because I think I did say that in the video, but there's 4 oxygens there, and I just thought it'd be nice to actually make the molecule of EDTA. Okay, so we'll stop that there and upload this.